They say that audio quality is more important than video quality. So today we're going to really test the limits of that. Also, it's 3 in the morning. Fireplace. Space. Don't know what that is. Welcome to the Relaxation Room. I'm your host. So today we're going to be talking about nuclear energy. Now, when I say nuclear energy, a lot of people are tempted to say, what even is the difference between nuclear and chemical energy? Don't listen to these people. Don't listen to anything they have to say, okay? You see them, you run. You turn the other way and you run. Okay, listen. Nuclear basically means you mess with the nucleus, and chemical means you mess with the electrons, okay? Nuclear, nucleus, get it? So when an atom is radioactive, it's basically shooting out these alpha and beta particles everywhere. I'll get to that in a moment. This is going to take forever. Okay. When an atom radioactively decays, it's losing protons. This changes the properties of the atom because the difference between hydrogen and helium is the amount of protons, aka atomic number. If helium loses an electron, on the other hand, it doesn't change to hydrogen. Miss Nunez from 5th grade science. An element's half-life determines how long it takes for half of the nuclei in the sample to radioactively decay. Atoms can decay with different particles. Alpha particles are helium nuclei without electrons. Beta particles are either electrons or positrons, which are like electrons, except they have a positive charge. They aren't protons. Miss Nunez from gamma decay doesn't shoot out electrons or protons or any of that stuff. It's just a result of a buildup of energy in the nucleus, usually due to alpha decay, nuclear fusion, or nuclear fission. It releases electromagnetic radiation in the form of gamma rays. Welcome back. Is that too fast? Let's talk about today's subject, nuclear weapons. What are they? What do they do? Isn't it just a big bullet? The answer to all these questions is no. Let me tell you why. Nuclear weapons, in this case hydrogen bombs, are really useful if you want to kill 1 million people at once. These bombs, they work by using a combination. It's fusion and fission. If you really want to understand it, just watch this guy's video. He explains it way better than I can. Also, it's pretty much where I'm getting all my information from. Hydrogen bombs work by having 2 isotopes of hydrogen, deuterium and tritium, fuse into helium atoms. Now this doesn't usually happen unless it gets really hot. We're talking like hotter than the sun hot. So you're asking, how does it get this hot? Well, the answer is more bombs. There's this orb of uranium, and around it is chemical explosives. They explode, and the beryllium casing reflects all the energy and puts pressure on the orb. The orb implodes on itself and reaches critical mass. All of a sudden, all this uranium is fissioning and throwing neutrons all over the place, and it gets real hot and steamy. The whole thing is full of styrofoam, and that turns into plasma. There are all these X-rays too, and all this stuff is hitting the second thing. This is a rod of plutonium surrounded by lithium-6 deuteride wrapped in uranium. Lithium-6 deuteride is the hydrogen part of this. It's the only easy way to get tritium in there. It's like a powder. All this heat means all these hydrogens are starting to get together, and that makes more neutrons go everywhere. The uranium wrapping starts acting up, the plutonium starts acting up, and then this has been the Relaxation Room. I am your host. Sleep tight.